All right, hey class. As promised, I said I would upload a video going over some review. So here it is. I actually made this for you because I looked at the test, I went through it, I kind of made very similar problems on this extra review. This PDF, this blank PDF is posted in Schoology in the review for the test folder. And I am going to do this with you in the video, the whole thing. And then I will post the answer key as well. So I really hope this helps. I think it will. I think it's worth it for everyone to watch it. So if you have a friend in the course, maybe say, hey, Mrs. Scott posted this great video. I think you should watch it. We're going to dive in. So there is a problem on there that just straight up gives you something like this and says multiply. So what they want you to do is FOIL. All right. So we're going to take the first times the first. 2 times 5 gives me 10 with this root 3. And this is just 2 times 6. So plus 12. On the insides, okay, I'm going to multiply the two outside parts together. So that's minus 20, 4 times 5. Root 3 times root 3 is root 9, which is 3. But we will do that part in a minute. And then negative 4 times 6 is negative 24 with a root 3. Let's take a look at what we have here. Okay, so like I said, square root of 9 is 3. 20 times 3 is 60. Okay, so I have 10 root 3 plus 12 minus 60 minus 24 root 3. So I can combine a couple things here. I can combine 12 and negative 60. So let's put that part first. So that's negative 48. And then 10 and negative 24 combines to what? Negative 14 root 3. That's the answer. You cannot combine that any further. The next section says true or false. So these are all a little bit tricky, which is why I put them on there. I just wanted to go over them with you. So the first one was something that we briefly talked about. If I have this like double radical situation, the trick is to multiply these indexes together. So 4 times 5 is in fact 20, which means this is true. Okay, they start to get tricky on us here. So let's see what this means. It says if x equals negative 8, then x to the 4/3 is 16. All right, so if x is negative 8, then what we have is this. Okay, so the denominator's 3. So that is going to be the cube root of negative 8 and then raised to the 4th power. So just be really careful here. Cube root of negative 8 is negative 2, and that's in parentheses raised to the 4th, which is, in fact, positive 16. So this is also true. Whew. Okay, I can tell you right now that C is going to be false. Do you know why? The only thing that should move down is the K. So this is actually equal to 5 over k to the 4th. They moved the 5 down with it, which they should not have. So that one is false. Okay, part D. Ooh, I didn't talk much about this. I believe this is true. Let's take a look. So think of it this way. If I were to rewrite this radical as a fraction, it would be this, x to the 6 over 9. And 6 over 9 reduces to 2 over 3. And if I then take that and rewrite it as a radical, OMG, it is in fact equivalent to the cube root of x squared. So that one is tricky. It makes you use your brain a little bit, but I'm glad that we're going over it in this video. And then this one is similar to letter B. this last one. Okay, so let's rewrite this. We're going to square root -4 and then raise it to the third. And I think right away you should have red flags. I cannot even root a negative. So this is actually a no solution. It is not equal to 8, so that one is false. So if you tried this on your own, you should have gotten true, true, false, true, false. Moving on. Feel free to pause the video. Feel free to rewind and listen to an explanation again, but I am going to try to truck through this because there's a lot of examples here. So the next one we just haven't talked about in a while. This is an absolute value one. It gives me no other information. So that is the situation where there's going to be two scenarios. All right, so when this happens, I'm going to take the inside and set it equal to 0. This will tell me that like breaking point where it goes from negatives to positives or positives to negatives. So I'm going to solve for x, subtract over the 3, divide the 5, all right, so now let's think of it this way. Oops. Think of it this way. So if I have a number line and I throw -3/5 on there, then something is going to be happening over here. Either every number I plug in over here, it's either going to be positive or it's going to be negative inside that absolute value, and then the opposite will be true over here. So let's just plug in a number and see which is which. So when x is greater than -3/5, I'm going to pick a number like 0. Okay, if I plug in 0 for x into this, then I get +3, which means all of the numbers over on this side are positive. Okay, and if I pick a number smaller than -3/5, like, I don't know, -10. So when x is smaller than -3/5, like -10, if I plug in -10 here, I get -50 plus 3, which is negative. So that is all I'm doing. All right, to actually write out the answer, this is what I'm looking for. So if x is less than -3/5, then we have negative, so we change both signs. -5x minus 3. If x is greater than -3/5, we have positives, so it stays the same. And underline one of those inequalities. I always try to do the top one. That's it. Hopefully this makes a lot more sense now than it did back then. All right, moving on. There will be one like this where you have to write this out, so be prepared. All right, the next one is something that is on the test, and we did not have a ton of time to discuss this topic. However, I will tell you this hint. The problems that are on the test are very similar to these two and only these two. So you will not have to do any rationalizing besides one problem that looks like A and one problem that looks like B, okay? You may think that number 6 is a rationalizing problem, but it is in fact not. I will show you the trick for number 6. So for this one, let's rationalize. Before we do that, I'm going to take that 9 and rewrite it as 3 squared. It's just going to be easier for me, and I will have to reduce less in the end if I rewrite it right away. So the index here is 4, which means I need groups of 4. So I am going to do, let's see, if I have 2 3s right now, I need 2 more. And if I have 3 x's, that means I just need 1 more. And if I multiply it to the bottom, I must also multiply it to the top. Okay, so across the top, multiply 5 times this radical. That's just going to give me 5 times the 4th root of 9. 3 squared is 9x over, well, when I multiply these together, oops, I get the 4th root of 3 to the 4th, x to the 4th, which 3 to the 4th, x to the 4th is just 3x. x. Now, let's say that 3 was something like 10, then I would reduce these numbers. But if it's not something that you can reduce, you just leave it. This is my answer. All right, part B, another rationalizing problem, but this time I have a binomial, which means I have to do the conjugate. Okay, so I'm going to multiply the bottom and the top by 4 minus root 2. So you simply change this sign. Whatever it was, if it was positive, then it turns to negative. And this is actually the difference of two squares formula, dots, where the middle terms are guaranteed to cancel out. That's why we can do it. So 4 times 4 is 16 minus 4 root 2 plus 4 root 2. Those should always cancel if you do this correctly. And then root 2 times root 2 is 2, so minus 2. Whew, okay, so on the bottom, we get 16 minus 2 is 14. Now on the top, we're going to take this 6 root 7 and distribute it. So 6 times 4 is 24. Root 7 minus 6 root 14. So when you multiply radicals, you do multiply the insides together. So there are two ways to write this answer. What I have written is totally acceptable. I will accept this on the test. Don't cancel out the root 14 with the 14 because one has a root around it and one does not. So this is acceptable. Technically, it can be reduced because 24, 6, and 14, all the outside numbers are divisible by 2. So I would also accept the following. 12 root 7 minus 3 root 14 all over 7. So both of these are acceptable answers, okay? We are not yet in the factoring unit, so I don't expect you to factor on the top and cancel, but it is possible. So if you realize it, then by all means, go ahead and do it. So those are the two rationalizing problems to look out for on the test. Number 5 is a simplifying problem. I feel like we've been through this so many times, so hopefully you feel great about it, but always good to get some extra practice in. So we are fifth rooting. So 32, the fifth root of 32 is 2. So we got 32 times 2. The x can be broken down as x to the 15th with 2 left over. And then the y's are going to be y to the 10th with 1 left over. And I will highlight all the things I can fifth root. 1, 2, 3. And then I'm going to fifth root them. So the fifth root of 32 is 2. The fifth root of x to the 15th is x to the 3rd. And the fifth root of y to the 10th is y to the 2nd. And whatever I didn't highlight is left over inside. Alrighty. Now for that number 6. It looks terrifying. It is not bad. Okay. It looks worse than it is because there is a trick that makes it an easy problem. Here is what you want to do. All right. Do not start rationalizing this. First, multiply the two top parts together. To do that, we just multiply the insides together. Okay. We have the 4th root. 6 times 8. 8 to the 5th. B to the 7th. Over the 4th root of 4ab squared. Now, I know people that will start rationalizing this, which is possible. However, you don't need to do it because if you have the same root over the same root, what you can do is this. Make it one big root. 48, a to the 5th, b to the 7th, over 4ab squared. And what's really nice about this is this actually reduces. 48 divided by 4 is 12. 5 minus 1 is 4, so this is a to the 4th. And then 7 minus 2 is 5, so then b to the 5th. All with a 4th root. Now, oh my gosh, now the denominator's gone, so I don't even have to rationalize. I will reduce this, but that's it. The b, I'm going to split up as b to the 4th, b to the 1st. I don't have to split up the a, and there's nothing that goes into 12 that I can 4th root, so I'm just going to pull out the a and the b. 4th root of a to the 4th is a. 4th root of b to the 4th is b. And I'm just going to leave everything else in. So this is the answer. It's the same answer you could get if you rationalize, but that would include a lot more work and room for errors. Whew, all right, down to the last one. This is just reminding you how to add, subtract with radicals. So we reduce the radicals and then combine. The first section here, or the first term, cannot be reduced at all. So I'm going to leave it. And that's actually a hint. I'm going to take the other numbers and divide them by 4 because that is a huge hint that I'm going to have 4x squareds in all of them. All right. Now, I know we don't get a calculator, okay? So, but just, I think you can trust me that this is 125 times 4. And the cube root of 125 is 5. So another 5 cube root of 4x squared. And then 32 is 8 times 4. And the cube root of 8 is 2. Drop down the other 2. And 2 times 2 is 4. So minus 4 times the cube root of 4x squared. There it is. All of them now have the same radical. They all have a cube root of 4x squared. So just combine the numbers in front. So 5 plus 5 is 10, minus 4 is 6. Final answer is 6 cube root of 4x squared. And that's everything. That's a great review. This is not everything that is on the test. This is not everything, but this is a good chunk of the harder problems. So I hope you watched the video. There is one huge hint that all the mental math seems doable, except there is one problem that forces you to do the 4th root of 625. And I thought that was pretty tough. So I would memorize that the 4th root of 625 is 5. Okay, so again, my apologies. If I had been there, I would just give you that hint. But I'm not going to be there, so I'm telling you on this video. All right, that's all I've got for you. Thanks for watching.